Velocity. The velocity of a moving body is defined as the ratio between displacement upon time. So therefore, because displacement is a vector quantity, hence velocity also should be a vector quantity. The directions of velocity is determined by the displacement. If the displacement is positive, the velocity is positive, and if the displacement is negative, the velocity will be negative. And or if the displacement is equals to 0, the velocity of the object also will be 0. Okay. Now, this velocity, it is same like a speed. For a speed, we write distance upon time. Okay. But this speed here, it is a scalar quantity. It tells you only about the number. Like the speed of a car is 40 kilometer per hour. So that 40 kilometer per hour, it is just the number. But velocity, if you see the velocity of a car is 40 kilometer per hour, then that it is the speed only. Okay, because velocity should has a direction. So when you say the velocity of a car is 40 kilometer per hour towards east or towards west in any specified direction, then that will give you the complete meaning of velocity. Okay. So therefore, the SI unit of velocity will be the same as the SI unit of speed, that is meter per second, and the CGS unit will be centimeter per second. Again, the dimensions of velocity, it is same as the dimensions of speed, that is m naught L t minus 1. Okay. Different types of velocity. Number one, uniform velocity. A body is said to be moving with a uniform velocity if it covers equal displacement in equal interval of time in a specified direction. Okay, for example, if you consider the motions of a car along a straight line, okay, let's say in 1 second the car cover a distance 10 meter, in 2 seconds 20 meter, in 3 seconds 30 meter, and so on. In which direction? Along this straight line. So the change of displacement in every 1 second is the same. Therefore, the velocity of this car is said to be a uniform velocity. Next, variable velocity. When the displacement, when the change in the displacement is not the same for the same uh, time interval, then that velocity is said to be variable. For example, in 1 second the velocity is 10, in 2 seconds let's say it is 40, in 3 seconds let's say it is 60. So what is the difference from here to here? This is 10 meter, this is 20 meter, this is 20 meter. Okay, so it means the change in the displacement of a car is not the same in the same interval of time. So that type of velocity is known as variable velocity. Okay. Next is average velocity. For average velocity, we define in the same way like for a speed. So therefore, this average velocity is defined as the total displacement upon the total time taken. If the car starts from point O to a point A, it moves along a straight line. So this is the directions of displacement. Okay. Now if the total displacement from O to A is 400 kilometers and the time taken from O to A, let's say it is 10 hours. So this average velocity, it is equals to 400 kilometers upon 10 hours, or it is equals to, when you divide you'll get 40 kilometers per hour. Okay, So this is the average velocity of a car. Okay. In which direction this car is moving? It is moving in the directions from O to A. That means along a straight line path. Okay. Number 4. Instantaneous velocity. Because this average velocity, it is not the same. This number 40 km per hour, it is not the same throughout the journey of the car. So at different time, the value of the velocity is different. Okay, maybe the direction is same because when a car is moving in a straight line, the direction does not change, but the magnitude is changing at every instance of time. So therefore, to define the velocity at every instance of time, we use a word called instantaneous velocity. So this instantaneous velocity is defined as the velocity of a body at a given instance of time in a given direction. So therefore, the magnitude of this instantaneous velocity, it is v equal limit delta t tends to 0 delta x upon delta t. Right? We will see this in the next video when we do the graph. Okay. You might have seen the speedometer in a car. So that speedometer of a car, it tells you what? It tells you about the average speed, not the average velocity. Okay, that means, right, it indicates or the amount of speed, how much the car is moving, but it does not specify in which direction is the car move. All right, so please remember that point. Speedometer always measure the average speed, not the average velocity. All right, okay. Now let us quickly see the difference between speed and velocity. Okay, the difference between speed and velocity are like this. Speed is a scalar quantity, that is, it has only magnitude but no direction. Velocity is a vector quantity, that is, it has both magnitude and direction. The speed of a car is positive, is always positive, or it may be zero depending upon whether the car is in motion or not. Okay. Whereas the velocity of a car, or I can say for any moving object, it may be positive, it may be negative, or it may be zero depending upon the displacement. Okay, alright. Now, another interesting difference between speed and velocity is, suppose you consider the motions of a body in a circular path. Let's say this body is moving with a constant speed, say 40 meter per second. So when this body is moving at a constant speed 40 kilometer per second, then what will happen to the velocity? Okay. Now, at point A, what is the speed? 40 meter per second. At point B, 40 meter per second. At point C, 40 meters per second, and so on. Okay, all right. Now, in which direction the body is moving using the concept of speed? That direction cannot be defined because speed, as I said, it only gives the numbers. Okay. Now, what is the velocity at this point? Will it be 40 meter per second? Answer yes. That 40 meter per second stands for the magnitude of velocity. So the magnitude of velocity means speed. The magnitude of velocity is speed. Okay. So the magnitude of velocity here is 40 meter per second, 40 meter per second, 40 meter per second, 40 meter per second. But in which direction is the car move at these different points? The directions of an object at different points on the circle, it is the tangent to the point. This is a tangent to this point. Now the tangent gives the directions of velocity, and we write VR with this. Here, this is the tangent, so it means the directions of velocity, it is in this way. Here, the directions of velocity is like this. This is the directions of velocity. So, though the magnitude of velocity is the same as speed, but velocity, the directions of velocity is changing from time to time. So I can say that this motion here, it is a non-uniform motion, right? Non-uniform motion because the velocity is changing its direction at every instance of time. Okay, so that is a small differences between speed and velocity.